Alright, so far we've formed bones through these processes of ossification, this intramembranous and this endochondral ossification. Then we showed how we can grow the length and the width of a bone. But even if you grow a bone in length and width, it doesn't have to stay that same length and width always. So we have this process of bone remodeling. Has these two, it can be divided into two parts. So bone remodeling, this process of getting bigger and making it smaller, is this process of bone deposition and bone resorption. So bone deposition, you're depositing minerals into bones. These osteocytes, these osteoblasts are going to make this matrix called the osteoid or osteoid seam. You'll get this accumulation of calcium and phosphate ions to make this hydroxyapatite, and you get the ions to crystallize into the salt. So we've already talked about all this stuff before. We had matrix, you get deposition of ions into this hydroxy apatite, and then you get the hardening of the matrix. Alright, bone resort, and what's the major thing that's going to make bone deposition occur? Like mechanical stress. So things like weightlifting, carrying heavy loads on the bones, that'll make them get bigger. Alright, bone resorption. So we've seen bone resorption, we've seen these osteoclasts breaking down stuff and remodeling into spongy and compact. But we can also take, instead of remodeling spongy into compact, maybe we break down that bone, and instead of having that hydroxyapatite being returned into these from trabecular plates into compact bone anatomy, maybe we just take those ions and put them back in the bloodstream. So let's see how we do that. How do we resorb bone? So these things, we haven't talked about them yet. We'll talk about them next semester. These things are called T lymphocytes. They're a type of immune cell. These T lymphocytes are going to activate our osteoclasts. So activate, I'll just put OC. And they're going to cause the osteoclasts to do two things. One, secrete enzymes. So just things that are going to speed up these chemical reactions to break down the bones. So we'll secrete enzymes, and the other thing it's going to secrete is hydrochloric acid. So if we go back a few steps and we look at this pH change. So when those blood vessels arise, the pH change, which causes that hardening of the matrix, that sort of stuff. When we talk about this pH change from the blood vessels, to reverse that, so the first step is to have this calcium. Whenever we're depositing bone, we have these calcium ions and these phosphate ions. These are soluble in liquid. When that pH changes, this is going to become an insoluble form called hydroxyapatite, or calcium phosphate. So these are your soluble ions, this is your insoluble salt. When your pH changes, your first pH change, you go from these ions, and then that matrix hardens into this trabecular plates. When we're resorbing, we're secreting hydrochloric acid, which is going to change that pH again. And when that pH changes, we go back from these salts, or back from the salt, this insoluble form, back into these soluble ions. So let's see if we can show this in a picture. I have my bone, and we'll just say here I have this stuff, this calcium phosphate, making up my hydroxyapatite. We know that this would happen. We looked at those secondary centers of ossification, bringing this stuff in, osteoblast activity, blah, 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 spongy bone formation. So we know these blood vessels brought something that changed this pH to make us go from these calcium ions and these phosphate ions into this salt. Okay, so now we have this bone and we want to resorb some of it. So these T lymphocytes, these T cells, are going to cause our osteoclasts to secrete hydrochloric acid. This is going to cause another change in pH. Let me draw a blood vessel. Here's my blood vessel. So when I have my change in pH, that's going to cause these calcium ions and these phosphate ions, or this salt, to become soluble, and they'll go from the salt version to these ionic, or these ion versions. So hydrochloric acid is responsible for the conversion of this insoluble salt, this hydroxyapatite, back into these soluble ions where they can then be put back into the bloodstream. So you have two options for where these ions are. If they're not in the bloodstream to be brought to other places in the body, then they're being stored in bone. Keep that in mind when we talk about these hormones affecting calcium. If something's not in the bone, it's in the bloodstream going somewhere else. When do we have it in the bone? We have that change of pH from the blood vessel made us have this calcium phosphate in the bone. Change in pH from these osteoclasts get us to have our insoluble salt go back to these soluble ions where they go back in the bloodstream. So that's bone resorption. Next we'll talk about some different factors controlling bone growth.